Alright everyone, welcome back to Cody's Lab. So a friend of mine recently acquired a mine and he has sent me a sample of the ore. He believes it contains platinum and palladium, and today I will be tasked with first seeing if there is platinum and palladium here, and second, developing a method to extract it. So unfortunately this rock has been ground into a fine powder, so I cannot see what the original rock looked like. I bet it was rather pretty. But it really doesn't matter for what I'm doing today. I would have had to crush it up anyway. So, the first thing I'm going to do to it is I'm going to zap it with this X-ray gun here. And I am going to see what elements it has. This thing has 30 elements currently loaded into it. Unfortunately, platinum is not one of those elements. But it should give us an idea of what we're dealing with. So first off, you see some sulfur, a little bit of chlorine and potassium. So this is probably a sulfide ore. There's about 2% calcium, 0.5% titanium, quite a bit of manganese. So that's probably manganese dioxide. That's one I will have issues with. About 4% iron. It's another one I'd like to get rid of, but that's not super high, especially for an ore. Let's see here. There's lead. Looks like about 40 parts per million mercury. That's not super high. In fact, that's probably lower than the soil in my backyard is. Rubidium. A little bit of thorium and uranium. Not enough to write home about. And we didn't detect silver or gold. Well, I guess there could be gold there, and there probably is a trace amount. But it's less than 3.6 parts per million, and if you actually look over at the graph, it just didn't get a good peak for gold, so it didn't confirm the presence of gold. Silver either. So that's what we're working with. The next thing I want to do is I'm going to take this ore and I'm going to go roast it. Extract all the volatiles, and if there's sulfides here, I'm going to oxidize them into sulfur dioxide and metal oxide. And the manganese, I will change that from manganese dioxide to dimanganese trioxide, which is less of a problem for me later on. Okay, so there's 200 grams of ore. Stuff is pretty light and fluffy. I might have to do it in batches if I want to roast a whole bunch. We'll start with this. Put it on this plate, kind of spread it out, and then we'll go put it in the furnace and see what we get. Uh-oh. Okay, it fits. So there we are inside the furnace. Let's bake. And here we are about an hour later. You can see that the ore has turned a nice terracotta red. Let's transfer it back onto the scale and see how much weight it lost during the firing. Look at that, 170 grams. Most of that's probably water. So what is that, 15% volatiles? That's good to know. Alright, let's put this in a plastic bag and let's hit it with the XRF again. Hit it right there. There. So the sulfur is actually about the same. That tells me it's not a sulfide, but rather a sulfate. Probably what's happened is this ore is oxidized, either in the ground or since it's been mined. Like say if he wet milled it, that would cause the sulfates to turn into sulfuric acid and probably react with the calcium, forming calcium sulfate. That would make sense. Manganese and iron, they're a little bit higher, but that might be just because the rock is now missing a lot of water weight. We got some silver. Not very much. 9 grams plus or minus 3 grams per ton. The mercury, if you look at that, that's dropped significantly, as you'd expect, because it's volatile. If we were roasting large amounts of ore, we'd want to collect that. Alright, and we still haven't picked up any gold. Nope. Okay. Now, let's see if we can get metal out of it. I think what I'm going to do first is a little fire assay, just to see if I can get a button of metal. I'm going to weigh out roughly 20 grams of the ore. Yeah, I might be able to go as much as 30. Okay, so we got 30 grams of ore. Now I'm going to mix this with some litharge, right there. Borax. Might be a lot of borax actually. And some washing soda. Okay. Get that all stirred together. I almost forgot the flour. Alright, so a little bit of wheat flour. So there it is in a crucible. I'm just going to put it into this little furnace here and cook until melty. Ah yes, nice and melty. Let's pick that up. There we go. There it is. Nice. And there's our metal. Well, it's not platinum or anything. That is just lead. I'm going to actually break the lead out of there. Maybe after it's cooled fully. There's the lead in the cupel. Now I'm going to oxidize it. And the cupel will absorb the lead oxide, but not the precious metals. The precious metals will not oxidize. Well, there we are. All the lead's burned away. There's a tiny, tiny bead of metal. Yeah, that's not very much. But I can get that out. We'll see what it is. Well, it's not microscopic, I'll give it that. It is rather tiny. I guess I can take it and see if it'll dissolve in nitric acid. If it's platinum, it shouldn't. If it's palladium, it will. And then I should be able to use the XRF to figure out what is dissolved. So I have placed a small amount of nitric acid down into this test tube. Now I'm going to get this little bead of metal and roll it into there. Okay, it's in, and it seems to have turned black. And what I'm going to do is I'm just going to set it inside the cupel, which is still warm, so I can heat it up and see if it'll cause it to react. So here we are. Most of the bead has dissolved. You can see there's a little bit of reddish gas from the nitrogen dioxide released, and a little bit of a dark colored powder. And that's either gold or platinum. Alright, so here's the results from that test. You can see that there is silver. Of course, I diluted it quite a lot, so it's still in the reading part per millions. And there's not enough palladium to show up on the alloy test either. Okay, so I just rinsed out the previous solution and I've replaced it with a little bit of nitric and hydrochloric acid, so this is Aquariga. I'm going to heat this gently and we're going to see if it dissolves. If it's gold, it should dissolve almost immediately, which it did. Okay. If it was platinum, that should have taken considerably longer. So yeah, I think that was gold, not platinum. Okay, so let's put this solution on a piece of paper as well. Okay. Also cover it with the plastic. Let's zap it with the X-ray. Alright, so now we can see that there is plainly gold. Can't really say exactly how much, but that definitely confirms that that little bit that I dissolved was indeed gold. Just so we're clear, the quantity of gold that I had there is consistent with maybe 1 gram per ton, which if you had a lot of it and you could process hundreds of tons at a time, it might be worth mining. But if you're packing it back on the back of a horse, yeah, there's no way. But just in case my fire assay was not accurate, if it didn't collect all the material together, I guess I can run this extra stuff just to see, if using a different method, if I get the same results. So to this 300 grams of material, I'm going to add some hydrochloric acid. Just enough to cover it, and hopefully dissolve out all of the base metals and metal oxides. This bubbling is not the material reacting, it's just the air coming out of the mixture. This really shouldn't produce much in the way of gases. All that already came off during the roast. So I'll just mix this into a slurry. I might heat it a little to help all the iron dissolve. Add a little bit more acid here to make it a little bit more runny. Ah yes, this is going great. So here we are after boiling in hydrochloric acid for a while. I think it's interesting how the mixture thickens up over time. It must be forming clays. That would actually make sense. Anyway, let's get the liquid removed and all those base metals washed out. Alright, time to vacuum filter. Let's pour in our slop and hopefully this will run through. Okay, so here we are. It took about 24 hours, but I finally got this washed. You can see all the solution is here. And I think I will save it just in case it contains some values. But I'm pretty sure all my values are going to be up here still. So let's actually put this into a bottle and let's do the halide leach. I'm actually going to take it out of this and put it back into this pan so I can mix it into a slurry. You know what? I've got the XRF handy. Let's take a piece of this, flatten it out, and dry it. And let's see what I was able to dissolve. Yeah, probably only need a piece about that big. There, dry. Alright, so the sulfur has gone down a little, not by a whole lot. Kind of makes sense because if it was calcium sulfate, the hydrochloric acid wouldn't have touched it. See the chlorine chloride has increased, which makes sense. Potassium's about the same. Calcium's gone down a little. So I did get rid of some of the calcium, but most of it remains. That's because calcium sulfate isn't all that soluble. Okay, titanium seems to be, I don't really remember what it was. Manganese is definitely dropped. Iron is down, not completely gone, as you'd expect, because the stuff is still red. There's still iron. But I have removed about 2/3 of it. Looks like about 2/3 of the manganese as well. In fact, I wouldn't be surprised if I dissolved about 2/3 of anything that could be dissolved. It's anything that was inside the grains of the rock that wasn't, if the rock particle was not split open so the acid could get at it, then it's going to still be there, right? Mercury's gone down a little. Hydrochloric acid does not dissolve lead that well. So yeah, you notice you're not seeing any silver or gold still. Of course, I forgot to hit record. Okay, so to make the leach solution, I'm just going to add enough hydrochloric acid to cover the ore once again. I'm going to mix it into a slurry, and then we'll put it into a bottle. For the halide, I'm going to use chlorine, and to do that I'm going to generate it in situ by reacting the calcium hyperchlorate with the hydrochloric acid that's in the bottle already. So let's start with just a little bit, maybe about a spoonful here. Actually, I might not even drop all this in. Let's see how much gas it makes. And this will just make calcium chloride. Alright, this seems to be alright. It shouldn't cause much problem. Just seal up the lid before the gas gets out. So now it's actually displaced the air. Ooh. You might be able to see a little bit of a greenish color. Now the chlorine should oxidize any noble metals present into a form that is soluble. You notice as the chlorine dissolved into the water, the bottle has shrank. That's good. Shows you roughly how much volume of chlorine is dissolved. So here we are outside, and I actually let this go for about a day. Now what I'm going to do is take this, pour it into this pan, and heat it to a boil. And that'll drive off all the chlorine. That's what I like about this. I don't have to actually boil it down. I can just bring it to a boil and the chlorine will leave. Okay, it's getting hot. Well, I don't smell chlorine anymore, so I think it's just about done. So now that this is dechlorinated and cooled off, I'm going to add it to this here filter, which I've added a little bit of an extension to it, as you can see. And we're going to filter out the liquid, which hopefully is pregnant with precious metals. So the solution does have a very nice color, though I am afraid that it might just be due to iron mixing with something else. This is taking a long time to suck through, so I think I'm actually going to combine two steps. So let's depressurize this real quick. That should stop dripping. Let's pull that off there just for a minute. Funnel. I'm going to add in a little bit of this ultra-fine copper powder, and this is going to cement out any precious metals. go. Put this back on. Maybe give this a stir. I'll suck it back down. Now I'm using copper because the copper won't dissolve in hydrochloric acid. But it will cement out palladium, silver, but there's no silver here, gold and platinum. This is finished dripping through. I've washed it with water a couple of times. So all our values should be down in here. And if you'll notice, the copper is, I think it's a little darker. It's kind of hard to tell. The liquid kind of covers it up. The liquid is a bit greenish. So that means some of the copper has dissolved, and I'm not sure if that's because of excess chlorine or if because it's replaced something from the solution. But there's no oxygen in there, so the dissolution of the copper didn't continue. Now that I've washed out all the hydrochloric acid, it's time to put in some nitric. This should dissolve the copper, leaving behind the gold. It'll probably also dissolve the palladium. We'll worry about that in a minute. Well, here it is after dissolving in nitric acid, and you can see there is some little black specks floating around in there. And those would be our gold and platinum. That is definitely more than I got from the fire assay, but it's not a huge amount more. It's about what you'd expect, maybe not quite 10 times as much, but yep. Well, let's see what happens if I add a little bit of aqua ammonia. Okay, so it turns a darker blue color as the copper is complexed. And I do not see any palladium precipitating out. So, I don't know what. There might be some palladium there, but I'm not detecting any.